So we started with nature inspiring the shape of buildings, and then we went to learning from nature and how we can actually construct buildings. And the next talk by Kyoung Kim from the University of North Carolina she's going to talk about how we can utilize organisms to actually help clean our environment.
First of all, thank you to Tricia and Carol and Chris for inviting me. And I also like to thank you to all the staff working behind the scene. Next slide. All right, so I shared this title very long time ago. So I tried to also touch about zero carbon architecture, nature-based solutions to decarbonate the built environment. All right, so I briefly introduced myself yesterday. So after I finished my PhD study, I joined a company called Front Inc. in New York City and worked as a facade consultant for 10 years. I work on a variety of projects that won awards for the technical innovations and also creative design. And if you can pay attention to this one, this is the James Carousel located in Brooklyn. It was actually used in an amusement park in Youngstown in Ohio. And the artist bought this piece of wooden carousel in 1980s and then spent 30 years to restore and they donate to the city. So it has some relation. I was working on the engineering and design of the enclosures, which was designed by the Jean Nouvel, French-based architect, Pritzker winner. So again, I started a new career as an entrepreneur. I launched a tech company, university spin-off in 2019 and tried to implement how to integrate these microorganisms as part of the building systems. I am also directing an interdisciplinary research lab housed in the School of Architecture at UNC Charlotte. This is the pre-COVID. So you see how clean it is. Now it's very messy. And you see over there is a spirulina still growing under nobody around it. All right, so zero carbon approach. As a professor who teach design studio and also technology courses, I want my students to be more proactive rather than reactive. And I told them that when your age become my age, you have to meet the zero carbon code or zero energy code. Right now, zero carbon practice is kind of voluntary. But I anticipate that to meet carbon neutrality, architects need to strive to become the carbon neutral buildings in the built environment. So this is the roadmap, how we can get to the carbon neutrality by 2050, put together by the International IEA, International something association. I think you hope can see. I cannot read the letters here, but at the bottom, that is the source that I got here. So in a nutshell, there are like 4 segments. The blue is, I think, the energy sectors. I cannot read it well. Yes, energy sector. And then the orange is the industry sector. And then purple is transportation sector. And then the green is the building sectors. By 2030, new buildings should be zero carbon ready, new buildings, right? But then 2050, all the new buildings and all the buildings got to be carbon neutral, right? So these are the goals that we are trying to meet. So to meet the carbon neutrality, first of all, reduction is super important. You have to find ways to reduce carbon emissions. You have to find ways to reduce energy consumption for the building. And then after that, we have to come up with a solution to sequester carbons that the building is using or the occupants are generating. So the circle on the right-hand side give you steps to meet there. I need at least 1 hour for each bubble to explain. But I think the Hans kind of touch on the bioclimatic design, meaning that when you design a building, make sure that your orientations are correct, your building shapes is correct, you fully insulate your enclosures, you have a right amount of the windows for the right orientation of the buildings, etc., etc. That is the first bubble. And after that, you have to think about how to integrate the energy-efficient building service systems, right? So right now, for example, lightings is super energy efficient. So most of them is renovated with the LED light. But then the HVAC systems, right? It has 7 to 20 years longevity. And then as technology evolves, the efficiency to burn the fossil fuels to serve the buildings getting improved, right? So you have to incorporate the building energy efficient building service systems. A third piece of the approach to meet the carbon neutrality is the renewable energy integration, meaning that every building will more or less require external load to operate the building. And we have to rely on the renewable energy sources to power the building, so such as solar panels, right? And then the last thing is the nature-based carbon sink. So upon you produce something, you produce carbons. Every commodities, activities comes with a carbon. That is why individual has a carbon footprints, right? So meeting the net zero energy is not enough. We got to strive to be carbon neutral to offset the carbon footprints that humans create. So the last two things, like using nature-based building materials and then incorporate nature-based carbon sink is important piece of information to meet the carbon neutral goal. I just want to quickly show you how much we are building and how much we're gonna build more new buildings. So in the United States, we have around 320 billion square foot floor area. So we already produce a lot of embodied carbons, right? And then to meet the increasing populations and economy, we will build 60 billion additional floor area. So there will be additional embodied carbons, and then we'll have a new energy consumptions to accommodate those developments. So then why microalgae? So microalgae is not new. It was used as a food source in early age, 1300. And then 70s, when we encountered energy crisis, food shortages, we also look at them as energy source, alternative energy source, and food source. And in recent years, NASA also looked into microalgae for their biologically life-supporting systems for the astronauts, and they tested it in the station in the space. Algae comes with different morphology and the species, but in a nutshell, it has 10% of its biomass, but it sequesters 50% of carbon sequestration on Earth. It does not require any arable land. It also does not require any fertilizer, and also it does not rely on the potable water. So again, the algae has so much rich morphology. Because I'm in the architecture field, I want to be inspired. So those are the kind of images that I often look at to, see how I can design bioreactors for the building. This also graph tells you how effective the algae is in terms of the carbon sequestrations. So because it doesn't come with the branches or trees trunk, it only has the cells. So it's a photosynthetic, the efficiency is superior. For that, also, it has a more high lipid density to convert them into biofuel. And if I'm from the North Carolina. So if we turn the North Carolina into microalgae field, literally we can supply 123 billion biofuels for running the transportation and hopefully cover the aerospace as well, airplane as well. So then I'm interested in building services, integrating the microalgae systems because it has a direct access to the sunlight. So microalgae rely on the sunlight and carbon dioxide to produce values for the human. And then the enclosures play an important role in serving energy for buildings. And then, views and aesthetics of the building enclosures are also very important for the user experience. So again, this is just some numbers for the American buildings in residential and commercial sectors. So the way I like to reduce energy consumption is that I want to control the density of the microalgae depending on the solar radiations and the number of the people. And the design approaches that make sure that there is a portion that users can look out, and there is a portion that microalgae can grow. I also incorporated automatic control systems that can maintain the systems and also monitor its performance. And then we are also working internally to evaluate its energy attributes, how much these systems could reduce the cooling, heating, and ventilation and lighting load. Again, 1 gram of biomass can sequester 1.8 gram of CO2. So you can have a direct convergence of the carbon sink based on the biomass I am harvesting from my building. And another, the background is that the American generate 5 gigatons, 10% of the world's CO2 emissions. And then if I can cover the 100 open parking lots for Lowe's, Walmart, etc., we can literally sequester all the carbon emissions produced by the United States. So again, another biological performance to show how much the oil is contained in this case, chlorella. And the air quality, I have maybe a couple of minutes. So another value propositions for me is improving the air quality. Can you play the video, please? So this video shows that, first of all, our aeration systems support the growth of the microalgae. We do not want to introduce too much high-speed air that shearing the microalgae that disturb them. But also, in the meantime, we want to, input the right amount indoor air to clean purify the air into the space. So this is another interface that we are working on to visualize the before and after of the air quality improvements. And then this is the version 1 first generation microalgae mockup. We grew 6 different strains, and you see that one of them is empty. That is a bioluminescent. We also was looking into way to incorporate the bioluminescent to eliminate the street light at night. And then we look at the end use of each strains for the food use and biofuel use and bioluminescent. I published a book last year. If you're interested in learning more about microalgae building enclosure, you can check it out. But then there are so many applications, speculations, implementations, testing around the world. And there are also, I also categorize them into infrastructural level intervention, urban level interventions, and also building levels and product levels. And this is a snapshot of how our technology could be a part of the building enclosures. With that, I will conclude my presentation.